Kelp comes up heavy with seawater, packed with polymers that can become film.
At the dock, each batch is weighed and tagged for traceability from ocean to package.
Even seaweed needs a cold chain when the goal is a consistent final polymer.
Next stop, the bioplastic plant, where kelp is cleaned, extracted, and transformed.
Moisture is measured first because water content affects yield and processing time. Washing removes salt and grit, so the chemistry downstream stays stable. Screens catch the heavy particles that would otherwise damage pumps and filters. Rotating washers clean fast while keeping the biomass intact.
Clean kelp is the foundation. Every later step depends on this moment.
Dewatering presses remove excess water to reduce energy used in drying. That captured water is often treated and reused, another sustainability loop. Next, controlled drying stabilizes the biomass without burning valuable compounds. Temperature and airflow are tuned to avoid uneven drying and brittle material. Milling increases surface area, so extraction can work faster and more completely.
Powdered kelp feeds the extraction line like flour feeds a bakery.
Sieving ensures uniformity because uneven particles create uneven chemistry.
Batches are stored separately, so results can be traced and optimized over time.
Extraction begins by combining kelp powder with water in large food-grade tanks. As the slurry forms, the target polymers begin to dissolve into the liquid phase. Mixing keeps the slurry uniform, so extraction happens evenly throughout the tank. Sensors track temperature and pH. Small changes can shift film strength later. Gentle heating speeds extraction while protecting the polymer's structure. Operators watch viscosity. Thicker flow can mean higher polymer concentration. Controlled dosing helps release the film-forming compounds from the seaweed matrix. Now the slurry is filtered to remove fibers, leaving a smoother, polymer-rich liquid. Stable pressure means clean flow. Spikes can signal clogging and trigger maintenance. After filtration, the solution looks clearer, ready for polymer separation and refinement.
Centrifuges can further separate fine solids that filtration might miss.
One stream carries purified solution, another carries concentrated residue for reuse pathways.
Sampling continues because consistent film depends on consistent chemistry.
To isolate the polymer, the plant changes conditions so it separates out of solution.
This is the moment the polymer becomes visible, like a net forming in water.
Separators collect the polymer phase while the remaining liquid is routed for treatment. Rinsing reduces salts and impurities that can weaken the final film. Pressing removes water and compacts the polymer into manageable forms. At this stage, it's no longer seaweed. It's a raw biopolymer feedstock. Pelletizing standardizes the material so it can be blended and processed like conventional plastics. Uniform pellets help control melt behavior and film thickness later. Storage conditions prevent moisture pickup, which can cause bubbles and weak spots.
Humidity control is quiet, but it's one of the biggest secrets to consistent film.
Now comes formulation, blending the polymer with safe additives that control flexibility and strength. Precise feeders ensure the recipe stays consistent across thousands of kilograms. Inside the extruder, heat and mixing turn pellets into a uniform, workable melt. Each zone is tuned. Too hot can degrade the polymer, too cool can cause poor mixing. The melt exits as a ribbon, ready to become a thin film. Casting rollers cool the material quickly, locking in structure and clarity. Film thickness is controlled down to tiny fractions because wrapping requires precision.
Curing stabilizes the film's final properties: strength, stretch, and sealing behavior.
Edge trim isn't wasted. Offcuts are collected and reprocessed where possible. Sensors scan thickness in real time to catch deviations instantly. Vision systems detect pinholes and streaks that could cause leaks. Tension control keeps the film flat. Wrinkles here become problems later. Dust control prevents specks that customers would notice immediately.
Some films use natural tints or prints, kept food safe and compost friendly. Printing must be aligned and low odor, because this film touches food.
Drying sets the ink so it won't smudge during converting and packing.
Slitting turns one wide sheet into multiple retail-ready widths.
Winding tension is tuned to prevent telescoping and edge damage. A clean edge is a sign that the process is stable and the film is consistent.
Some customers want rolls, others want pre-cut sheets. Converting handles both.
Cutting must be sharp and clean so sheets don't cling or tear.
Packaging is designed to protect the film from moisture and heat during shipping.
Moisture control can continue inside the box to protect shelf life.
Labels carry key info, batch number, date, and compostability standards.
Check weighers confirm every box is complete and sealed correctly. A small seal protects product integrity all the way to the customer.
Robots palletize fast and consistently, reducing damage during transport.
Stretch wrap locks the load so cartons don't shift and crush. Now the product is ready for distribution, tracked from lane to truck. Each scan updates the system, preventing mix-ups between different film types.
At shipping, the factory protects film from heat spikes that can soften or warp rolls.
Even at the dock, environment matters, because bioplastics can be more sensitive than conventional plastics.
Quality testing checks strength and stretch, so the wrap performs like customers expect.
These curves tell the story. Too brittle, too stretchy, or just right. Seal tests confirm the film can close reliably on packaging machines.
Barrier testing measures how well the film protects food from moisture loss or gain.
And compost testing checks whether the film breaks down under proper conditions.
The end goal is a material that returns to the earth without leaving persistent fragments. Documentation supports compliance because eco-friendly must be proven, not claimed.
Calibration keeps measurements trustworthy, which keeps quality stable.
Microscopic inspections catch tiny defects long before customers do. Small adjustments bring the process back into target, quietly and continuously.
Maintenance is built into production because reliable machines create reliable film.
A tiny scratch on a roller can become a streak on kilometers of film.
Residues are sorted too, because waste streams can become resources.
Some facilities convert fiber residue into additives for paper, board, or composite materials. Trim recovery reduces material loss and lowers the cost of sustainable packaging.
Water used in washing and extraction is treated because sustainability includes the whole system.
Biological treatment helps remove organics before water is reused or safely discharged. Solids are dewatered and handled responsibly, often routed to approved recovery channels.
Some plants pair bioplastics with renewable energy to shrink the footprint even further.
Energy monitoring turns sustainability into measurable targets, not slogans.
Ensure the foam covers the entire surface before we start rinsing.
We're almost finished scrubbing the main conveyor here.
Teams brief daily what changed, what to watch, and how to keep quality on target.
After all that process, the output looks simple. Just a roll of wrap.
But behind that simplicity is a chain of control, ocean biology, chemistry, and precision engineering.
The film must handle real life, stretch, seal, and protect food without off odors.
A strong seal means less waste because food stays fresh longer.
And at the end of use, the wrap is designed to break down in the right compost system.
From kelp ribbons to film rolls, every step is built around repeatable, measurable quality.
Then it ships out, ready to replace a little bit of petroleum plastic in the world.
It's a loop, ocean-grown biomass, modern processing, useful packaging, and responsible end of life.
That's what bioplastic really means here. Performance first, sustainability built in.
And just like any factory, the process ends with a reset, so the next run starts clean and controlled.
When you see a simple wrap, remember the hidden work: chemistry, sensors, and discipline.